Hey, welcome. So, this is a talk about a hard thing to do. The challenge of distributing free software, which is like herding cats. So, but first, as most of you don't know me, a little bit about myself. I'm Henne. For more than 20 years, I've been hacking free software. I'm self-taught. So while everybody was going to some nice university like Fur, I was touring with a punk rock band and selling skateboards for a living. In the mid-90s, I started some classic free software developer career. So first I was a user of free software, then I helped other users with their free software. Then I was an admin for many other users. Then I was an admin who was automating his admin tasks, which in turn led me to be a developer. Now my day job since 2000 is working for a Linux distributor, SUSE, where I manage a team of engineers that works on an application that is called the Open Build Service. And I still hack free software in my free time, so I'm a hacker of a conference organizing tool called the Open Source Event Manager for events like this, and I still operate many of the server infrastructure of the OpenSUSE project. I frequently also mentor other free software developers with programs such as Rails Girls Summer of Code or Google Summer of Code or at events like this. But enough about me. Let's talk about distributing free software. So the basic challenge of distributing free software is compiling all that awesome open source code into something that is usable and consumable for users. It sounds easy, but it isn't. So the question for a software project like Firefox is, how can I make sure that my users on different operating systems, different computer architectures, different operating system versions can use Firefox in a fashion that is easy for them? Now, back in the good old days, this was not really a problem. Everyone was a long-haired, peace-loving, bearded software developer. So the developers of Firefox would just release the source code. And then the Firefox users, who happen also to be developers, would gather all the requirements that Firefox has, take the source code and compile it for their machine. Done. Everybody was happy, the birds were singing, everything was great. Until one day, a couple of years later, free software developers became cleanly shaved hipsters. And the average computer user knew as much about compiling source code as all of us probably know about piloting an airplane. So this was really not an option anymore. So the free software community came up with the concept of packaging. So a developer does not only release the source code, but he also compiles it and compiles all the dependencies, wraps this up in a nice package and gives it to the user. The user then uses some package management application to help him get the software. Cool, solved. But for the developer, this all of a sudden means that he now has to produce a package for the software he's shipping, Firefox, but also for the libraries it needs and also the tools it needs to function. And then around 2004, the first 64-bit processors came about and got popular, which meant the developer needed to build packages twice, once for 32-bit and once for 64-bit. And of course, there are also some other CPU architectures around, like ARM, that people use and may want to use Firefox on. Now, this is a lot of different packages for one developer to create. And the developer also has to make sure that the software he gives to the user works together. So in the package, he needs to express, okay, my Firefox needs libfreetype. My Firefox needs shared MIME info, and shared MIME info needs libxml2. So transient stuff. And conflicts, like Firefox won't work with libfoo. And libfreetype needs libfoo. Oh shit, libfreetype needs libfoo. Firefox needs libfreetype. I can't install Firefox anymore. And that's not all. So developers want to make the software better, right? So all the time, like adding new features, fixing bugs, and so on. So all the software is versioned. And it might differ in behavior between versions. So the developer has to do something like this. Firefox needs libfreetype in version 1.0. And Firefox needs libfreetype at least in version 6.0. Or Firefox can't work with libfoo in version 3.2 or later. And libfreetype, same thing, everything crashed. And that's something where even rather simple applications, you soon up in a place they call dependency hell. So where you have dependency trees that are so complicated that you cannot solve them easily. Now, this is a good way to drive software developers mad, especially if the software you are trying to ship to the user has to work on the system of them together with another application that you don't have any control of. So the user's Firefox should also work if he has LibreOffice installed, right? And all of a sudden you have two dependency hells combined in even bigger hell. So abandon all hope, ye who enter here. So this is when the free software community came up with the concept of software distributions. So the stuff that you see here, all the nice distributions that you all probably know, are just groups of people who specialize in installation of an operating system, mostly Linux, and managing the dependency hell. So for the Firefox developers, this boiled down to this. So my Firefox needs libfreetype. Oh, OpenSUSE provides libfreetype, and Ubuntu 2, and Fedora 2, awesome. Or more specifically, my Firefox needs libfreetype in version 3.0. OpenSUSE has 3.4, Ubuntu 4.2, Fedora 6.0. Everything is fine. Everything, the birds are singing, everybody's happy. So this in turn led to application developers simply not distributing the software anymore because the distribution people took over this for most of the projects. And they also started to work on sync points, so stuff like, okay, GNOME releases their new version in May, then there's a new long-term support kernel coming out in July, so let's release the new version of our distribution end of August. This was working fine. Until some time ago, free software development started to look like this. More awesome developers. Or even like this, a buttload of new awesome developers. So that increased and increased until our model of shipping free software through distributions started to blow up. Because software in general had its breakthrough. A lot of people started software development, and in turn, a lot more people were involved in hacking free software, including many that are doing this on a professional level. So nowadays, there's so much free software released and in an ever-increasing pace that there's a strong need for the developer to take over the distribution again. So we are back to square one. Now, since a few years, people are trying to figure out this problem, and there actually have been quite a few solutions proposed for this. So one, very obviously, and most prominently, is the web. Lots and lots of applications moved into the web because it reduces the complexity to ship your software. You can do heavy computing on your server somewhere that is handcrafted by you and just do the rendering of the application on the user's computer. Another solution for this problem is, and that is quite hip right now, is isolation. So you just create your own little computer in the user's computer that is isolated and that you have control over, so you only have to take care of your own little dependency hell in it. This is something like virtualization or container stuff like Docker, Snappy, App Image, Flatpak. And by the way, for the isolation stuff, at 2:15 today, there will be a talk of Robin, who I think will talk about the pitfalls of this distribution method. And after that, right after that, Luca will come and tell us about another solution to this problem, which is Nix, which I believe is a solution for this problem because I didn't really look into it yet. So if you're like me and want to get an even deeper picture of all of this, make sure you don't miss those talks. But anyway, so the third solution we have to this problem is automating packaging. Because, quite frankly, packaging software is rather clearly defined and a repetitive task. And this is, as we all know, those are the best things that computers do. So let me tell you about a little application I work on, which is called the Open Build Service. It's a tool for free software developers like me and you that want to automate their shipment and updates of packages to their users. Which brings us to the demo time. I need you all to do a little prayer to the demo god, because otherwise this will all crash and burn. All right. So, it already crashed. No. So. You can see this, right? So, the Open Build Service. It didn't crash. That's just my cleanup tasks. So, here we are, the demo. Let's just make a temporary directory. And then all of this is live. I'm just echoing what I do. So cd into it. Then I have a little application that is called Hello Zagreb, which is on GitHub. So let's clone this. cd into it. And then let's explore the checkout. So here's my Git checkout. There's my application. It's very simple, a nice Ruby application that just puts out Hello Croatia. So, and there's in my dist directory, there's an RPM spec file, very simple boilerplate RPM spec file with some metadata and some building and copying things around, nothing fancy, just some packaging recipe. Okay, that looks good. Now let's get out of there. And then you have the Open Build service has a command line client, which is called OSC. So where I can also check out, just like with GitHub and Git, I can check out my project, which is called Henne Vogel Demo. So let's go into that, make a little package. This is the command to make a package, mkpack. Hello Zagreb, cd into it, then we can explore it. So it's empty, right? So there's nothing in there. Now, I can tell the Open Build service that this package lives in this GitHub repository, which will in turn create a service file for me, which I can look at. It's a simple XML file that has a couple of services defined. So you see it's starting tag service and ending tag service. So this one is the service that just happens to know where the Git repository is. This one is the service that tells it, okay, whatever's in Git, put it in a tarball. And this service is called recompress. This just recompresses every tarball into tar.xz, so with compression. And then we have a service that is called setVersion that will set the version of my package. For that, I need some more parameters in the first service. One is called extract, which tells me, okay, extract this spec file from the tarball, because this is how we are going to build it. And the version format is something yada yada text in Git. All right. So, sounds cool. Let's release the first version. So I just commit my changes. It uploads it to the server. And if my colleagues are as planned on their lunch break, then everything will go fine. So let's explore the result. My OSC checkout just has one file, which is called service, and I can look at the results. Oh, OpenSUSE is already building, so I can look at the OpenSUSE build log. Ah, it's doing something. So, without me doing anything, just adding an XML file, I somehow get a package built. So, as you can see, this installs all the stuff that it needs for building this package, and then we'll do blah, blah, blah. And in the end, I get a nice RPM package out of it with the version 0.9. That's cool. So for users, this was for developers, right? For the users, they would just have to input this URL in whatever package manager they use. For me and my laptop, this would be OpenSUSE in zipper. So I just put this in, and so it added the repository, and then I can just install my little thing. Let's hope this works. No, it doesn't. So, but anyway, I could, the package, if it has finished the build, or if it's available on the mirrors, because between building and packaging there has to be a little time where it has to appear on the mirrors. It's not. Maybe later, maybe even later. But anyway, obviously you didn't pray enough, this crash. come on. Looks like it is hanging currently. Which we can also look at. No, we cannot. Oh, which we can also look at in the browser, because the build service not only has a command line client, it also has a web interface. So I can look at this. Here's my Hello Zagreb package. And it's hanging in Finnish because somebody didn't go to lunch. It's blocking me. Anyway, so at some point in time, this would finish, the package would be published on the server, and then I can install it, and I can just call it in my system, and it would output Hello Croatia. All right, so as all of this works, but only whenever I check in. So why not let GitHub do all of this? Let me switch back to this. So for that, I can create a token in the Open Build service. I can create a token that says, whoever has this token can do whatever he wants to this package. So let's create a token. Whoop. This creates a nice randomized string, which I can go to GitHub with. So this is the GitHub repository I was checking out. I can go to settings, integration and services, add a service called OBS, which says yada, 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 and wants my token. So I now have the token, which means whenever I commit something, the package will be built with this new commit. So this is working fine. So let's go into the Git directory again. So out of the OBS into the Git, and I can make a new release. So let's say I want to be more specific with the greeting, right? So not Croatia anymore, but Zagreb. So this is the change. I can say, okay, I can say, okay, be more specific with the greeting. Wants my password. So I can say, okay, this is version 1.0, right? So I can then also save change the spec file and say there's this description here, which is also for Zagreb. So I commit this too, fix the spec file. So now if I push all of this to GitHub, you will see that at some point in time, Oh, it's building again. So GitHub triggered this. I can look at the build log again. And it's building, building, building. Again, a few seconds. And in the end, it will create a RPM package for me. With the version 1.0, which didn't work, and I don't know why. But it would work, normally. Not in a demo, where nothing works, but normally it would release a version 1.0. So for the user, so speaking as a user again, for the user, this would then be a simple job of zipper up, hello Zagreb. And my users would get every commit as a package. So this will obviously also not work. Okay, so this was the short demo that also crashed. So, but of course there's even more things you can do. So let's say I don't want every time I do a commit to have the user a new package, because this would be like every couple of minutes probably in a big project. So I can do the same setup I have showed you now in my development project, and then at some point that is convenient to me, like every week or every time I feel like it, I can do a release of the things into a normal project, which then means for the user, he only gets the package once this is done. I can also release for other things like the isolation stuff that we talked about, because the OBS also can build for those. The OBS also supports collaboration for people, so I can do the normal free software flow, like branch, change, submit, merge. So I can branch this package, I can change some code in it, then I can say, hey, Henne, I fixed the bug in your code. And then at some point, if you're lucky, and do a submit request to me, I will say, hey, accepted, thank you for fixing this. So this is also something that is built in. Another thing is, sometimes you want to maybe plug in other tools, like your CI cycles, your continuous integration cycle, so where your tests run. You can use the same feature for this, so you can make a release request, and on this release request add a reviewer like your CI user, which then, after yada, 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 either says, hey, this is accepted, or hey, no, this didn't work. And just so you know, I'm not telling you about bloatware or about vaporware that doesn't exist. This project is now 12 years old. Distributions like OpenSUSE use it. They built 36,000 or more than 36,000 binary packages with it and release it to their users nearly weekly. On the other spectrum, there's SUSE, which is the company behind OpenSUSE, who support with that tool Linux distributions that are more than 13 years old. So sometimes people phone me up and say, hey, Henne, you have to fix this bug in this 13-year-old code. So I need to go back, check this out, stuff like this. So what are you going to do with it? Check out this URL. Thank you.
Are there any questions?
If you want to see the demo working, maybe you can come down afterwards and I can show you, figure out what's wrong. Thank you.